is probably a tie between Full Metal Jacket and Pulp Fiction. You guys should not see Full Metal Jacket. You shouldn't see Pulp Fiction either, quite frankly. Huh?
How between Disney and Pixar?
It's not the same. Pixar infinitely better at storytelling.
Probably maybe Cars? No, Toy Story 3. Toy Story 3. Yo.
Have you watched Whiplash?
No.
Okay, that is something. It's definitely a must watch.
Okay.
Technically and like the story, it's amazing.
Yes, Ethan rattles about it all the time. He's probably worth watching if he talks about it this often.
This is the first time I mentioned it.
No, that's not. Oh, in this class, for sure.
All right. What's the answer? No. 15x squared. Why?
Why is it that? Because they're like terms, and because
5 times
two
3
things
is
together.
15, and x times x is x squared.
Because they're
Mr. Myers.
What?
It's because if you take 5 x's and you multiply it by 3 x's, then you multiply the 5 by the 3, and that makes 15, and then you multiply the x by the x, and that makes it x squared.
So exactly what Roy said.
Yes, but
Word for word. Okay. I'm glad we agree.
that's not word for word.
So what would this be?
Or is it something
Why?
because they're not like terms.
They're not like terms. Okay. All right. So you already know how to multiply coefficients and arguments, yes? Radicals are the same thing, except there's a weird rule. You can only do it if they have the same index, but even that is tricky, and everybody should pay attention here because this is going to get weird. If they have the same index, and I'm going to write a very mathy, technical word here, kinda. Okay? This root 7 times cube root 7 is actually something that you could do. Okay? That would be okay, even though they've got different indices. Root 4th root of x times 3rd root of x. That would be okay, even though they have different indices. Everybody cool? That's the plural of index. A lot of people don't know that. People say indexes. They're dumb. It's indices. Just like codex is codices. If you've seen, of course, those horrible movies, the Mona Lisa, Drive Project, whatever the hell that was, Angels and Devils with Tom Hanks' worst movies ever. Da Vinci Code, that's the one. Angels and Demons. And then he's in one more, I think. Yeah, Inferno, which I didn't even bother to see. Or read the book.
They're kind of dumb.
Anyways, he's searching for a codex in the first one. If he was searching for more than one codex, he would be searching for codices. Anyway, these two are okay. Why? What about these two do you think makes it so we could do this work? Ethan.
Because they have the same radicand.
They have the same radicand. And these, you don't know how to do it yet, but these can be converted into exponents. And because they have the same radicand, the radicand becomes the base. So you can actually do these, even though they have different indices. But this square root of 15 times the cubed root of 5. That is a no-go. Everybody cool? Now, just out of curiosity, don't write this down. Do you think this would be cool? The cubed root of 16 times the square root of 32.
Yes.
No way. Is that cool?
Yeah, that's cool.
Would it be cool?
I've heard yes, and then upon second thought, I think so. A bunch of people say no. Ethan was like, yes! And then now that I'm talking, his hand went higher, and now that I've kept talking, his hand has gone to here, and now it's down.
I just wanted to say cool as ice, not gonna lie. I didn't actually look at the
Could that one be done?
Sure. I'm just gonna say sure.
When you have like x squared and you multiply it by x, that's x cubed. So could you apply something? What is it?
This is 2 to the 4th, yes?
Yeah.
This is 2 to the 5th, yes? Do they now have the same radicans?
Yeah.
So we could do that as well. Everybody cool? All right. But all the kindas, don't worry about them, because when we get to section 111, you'll learn about all the kindas. But for our purposes, if they don't have the same radicand, even if they have the same radicand for right now, if they have the same radicand but different indices, you don't do anything with them right now, okay? So this one right here, they're the same indices, so we can do it, right? And all you do, it is exactly like this. You bring something you already know to this party, because this behaves like negative 7x times 5y. They behave the same way. So, of course, you would do negative 7 times 5. Then you would do xy. But in this case, it is the root of 3 times 8. Everybody good? And that, of course, is negative 35 root 24. And a great many of you would stop there, because when I show you something new, you think that that is the only thing you need to bring to the party. Did you learn math before today? Yes. Have I told you millions of times? That's hyperbole. Have I told you millions of times that every piece of math you have ever learned is needed every single day of class? Yes. So, of course, previous math is needed. You, of course, would remember to simplify 24. To 4 times 6, you would bring out the 2, and you would get what for an answer? Negative 70 root 6. And, of course, because blue and red make purple, I will write negative 70 in purple. Is everybody good? Excellent. So, what then is going to be the answer to B? It will be 3 root what? 16. Why is that 3? Because what's not written there? 1. And of course, you don't stop there, because the root of 16 is? So this is 3 times 4, so it is indeed 12. Yeah? Yeah. Is C any different than A? No, of course not. It's just written differently. A is written the way we wrote multiplication when you were in grade 6. C is the way we write multiplication for the rest of your lives. So what's this going to be? He waited patiently. Don't give me the answer. Just give me the next step. Look. Negative 48. I don't need brackets. Sorry. Negative 48 root 72. Do we stop there? Of course not, because 72 is 36 times 2. Why did I use 36? Because it's got a square root. What is it? So what comes out here? So I get negative 288 root 2. Ya, ya? Ya, ya, ya. What is D going to be? 3 root 9, which is 9. Because the root of 9 is 3, and 3 times 3 is 9. Ya? Okay, E puts the last two lessons together, yes? Right? Because there's adding and subtracting. It also puts lesson 1.3 in there because it's also distribution. And it puts today's lesson in there because when you distribute, you multiply. One question covering 5 lessons. What is it? What's this first one going to be? 15 root 16. What's the second one going to be?
10.
And what's the third one going to be? Now you will notice I am not writing this out, right? Okay? I'm doing this math we are all doing this math in our head, yes? But cast your mind back. No. I'll talk about that next question. We'll stop. We'll finish this one off. What is the root of 16? 4. So 15 times 4 is 60. Plus 4 times 6. What is it? Simplify that. 20 root 6. Minus, what's this? What's a perfect square that goes into 40? 4 times 10. Square root of 4. Negative 10 root. What do they leave under there? 10. Done. Everybody good? Ease bees lemon squeezy, yeah? All right. Now, if you have only been following steps and paying attention to the one new thing you have learned, then if you were to approach this question, you would have to simplify the square root of 864. And that's not just a factor tree, that's a factor redwood. Right? So, of course, you bring other math to the party. You simplify first. But you have 2 options. You could simplify here, which would be 8 times 2, right? Why did I choose 8? Cube root, so it would give me 2 cube root 2. And this is, of course, 27 times 2, yes? Which would give me 3 cube root 2, yes? Which would give me 6 cube root 4, right? That's option 1. Option 2 is you could do this. The square root of 16 times 54, and then break them down there. Still a cube root, 2 times 8, 2 times 27. There's your 2 cube roots, and you left 4. It gives you the first breakdown of the 864. All right? Don't be mindless drones following steps. You're better than that. Okay? Bring math to the party. So looking at G, now you know what you know. Would any of you try to do 28 times 63 and then break that down? No. Of course not. You'd simplify first. What's this guy going to be? I would use, 4 and 7, so what comes out? So it's 10 root 7. What's this guy? 9 and 7, so what comes out? So it's 9 root 7. What's 10 times 9? 90. And what's 7 times 7? What's the square root of 49? What's 9 times 7? Plus a 0. 630. Yeah, yeah? Yeah, yeah, yeah. What makes H a pain? What makes this a pain? You should all say nothing. Because isn't that just double distribution? So you know what to do there, don't you, Pilgrim?
Sometimes I switch between less.
That's okay, man. Right? So, let's go. What's the first one going to be? 4 root 24. What's the next one going to be?
6 root.
What's the next one going to be?
6 roots. 21.
And what's the last one going to be?
6 roots.
Nope.
No, not 6. 9 roots. 14.
And then what do we do?
But no.
Simplify. What's this?
That's, yeah.
So what comes out? 8 root 6. What's that?
4.
So minus 24. What's that?
21. Oh.
6 times 4. What's that? Any pairs? Get any simpler? What's that? What's that? Any pairs? So get any simpler? And it's done. Everybody cool? All right. So, you have a blank page, yes? Let's get some questions for it. Where did I put those? Go. When we have done 4 or 5 of these, we will do our quiz. I think. I got to check the length of that quiz, see if you can handle it.
No, let's go. We can do it, gang. You not believe in us? No. Why not? Didn't we just do like 6 of these questions? Didn't we say that all of the questions on the practice are on the quiz one? So shouldn't we be able to do this really easily? Oh, darn. Oh, yeah, you're right. Oh, no, this is going to be impossibly difficult. Oh, man.
It doesn't work in art, so you don't really try art on it.
Right. Just touch the it's easy.
Something weird's going to happen with those first 2.
So you got to do that. Right?
Something weird is going to happen with those first 2.
But is there going to be multiplies?
No. Those first 2 are going to, something weird's going to happen that is very important for the next thing we're going to do. That's why I've given you these. And it's going to happen twice, so you should be able to make a mathematical conclusion about it. If you've multiplied correctly.
Wow. It's insane. Oh, I'm just cross these 2 out because they're the same. Get out of here. That one.
I did this on purpose because it's leading me to my next question. Because really, multiplying radicals is not difficult, is it? So I might as well use multiplying radicals now while we're talking about it to help me prepare for the next thing, which is dividing radicals, which does become a pain. It's the first thing about radicals that's actually, woo! But you've seen this, so you should be cool. So what's this first one? 64 root 4 minus 40 root 12. Then what? Plus 40 root 12. And then what? And what's the square root of 4? So that's 128. What happens here?
Cancel them out.
They're gone. And that's what? Minus 150. Negative 22. Please notice, what were there 4 of in the question and none of in the answer?
No, wait, no.
Somebody said it. Radicals, right? We were able to eliminate 4 radicals, right? So now you've seen it happen once. What would you say, how would you compare those two binomials? What would be the thing that you, like if you were to describe those to me, what would you say?
Why does this fit?
Pardon me?
What was your question?
What are you answering if you don't know the question?
I was wondering what the question
I'll
was.
figure it
But you answered before you asked what the question was.
I misunderstood the question.
But then why would you give an answer?
Because that's what I thought, but I thought again.
What?
Okay. How would you describe these two binomials in comparison to each other? They're almost the same, aren't they, Shayla? What is different? Gideon.
One is subtraction and one is addition.
One is subtraction and one is addition. Is that same thing happening here? Now, once you've done this once, what do you know you can now do here?
The same thing again.
The same thing again. You only need to care about firsty and lasty, because you know the middle is going to drop out. Right? So this becomes 81 root 25 minus 36 root 100. What's the root of 25? 81 times 25 is 81 times 5. No calculators. What's 80 times 5? 400. What's 1 times 5? I know it's 405, Ethan, but a great many of your peers were not able to get to it that fast, so I'm giving them a little trick that might help them. It is 405. What is the root of 100?
10.
What's 36 times 10? It should not have taken that long to hear those answers. And the final answer? 45.
It's a minus sign.
Yes.
I like that.
Everybody cool? All right. Keep these two questions bubbling near the top of your brain for tomorrow's math class.
Or we have the quiz.
And then let's do this one. Find the area of the rectangle. Well, math teachers love to do this, because what's area? Length times width. It's just multiplication, right? It's how you were taught multiplication. Mrs. Bad Crumble drew a rectangle and said, 2 times 4. 1, 2, 3, 4, 5, 6, 7, 8, Mrs. Bad Crumble. At least she should have. What she probably did was gave you jump math or some garbage like that and had you counting on your fingers. Probably not you. You're a little too old for that. Or my favorite, 63. The 9 times table with the fingers. Drives me up the wall. Huh? You guys got a buddy out there? Do I gotta go kick some ass? All right. So 6 cube root 40 times 2 cube root 135. What would a dummy math student do?
Not simplify.
He would go 40 times 135 is 4,000. But not you. What are you going to do first? you're going to make that 8 and 5. Why? Because 8 has a perfect cubed root. What is it? 2. So it's 12 cube root 5. What about 135? 27 and 5. Oh, what's coming out? So it is 6 cube root 5. Now, if you're not thinking, you might say to yourself, self, when I have a radical and I multiply by a radical, I get the radicand. Is that the case here? No. Why? Because it is a rule, but they got to be the same index. They got to be square roots to do that. They're cubed, right? So the answer is 72 cube root 25. That's not 5. Everybody with me? Now let me ask you this. Now that we've talked about that, and now that we've talked about the square root of x times the square root of x equals x, how would I get rid of a cubed root of x? What would I have to multiply it by? I would have to multiply it by x cubed.
No, never mind. No.
You would have to multiply it by x 3 times, right?
Which is x.
That's cubed.
That would be x cubed. Yes, I could cube that, right? Which would get me cube root of x times cube root of x times cube root of x, which would get me the cube root of x cubed, which would be x. That will work. Is there another thing I could do that looks like that? What would I multiply the cubed root of x by if I wanted to make this happen in one step? What?
The cube root of x or x squared?
Yes, the cube root of x squared. Because, of course, x times x squared is the cube root of x cubed. And you could automatically get rid of that step. What would I have to do if it was the fourth root of x? What would I multiply by? X cubed. Huh? Everybody see? Math. All right. I got 905. I got 8 open-ended exponent questions, 2 multiplication of polynomial questions, 2 a GCF question, LCM question, and 4 radicals to simplify. You got 25 minutes. What do you figure?
Let's just do it.
I think you should try it.
Let's do it.
It's not a test, so
I know, right?
why don't we just
I know. This is when you practice actually getting good at math. Because it doesn't count.
This is my absolute all-time favorite band.
Favorite what?
My favorite band.
Band?
Yeah.
Dividing radicals?
It sounds like a band, and it looks like it should be a band.
Okay. All right, clear your desks. Let's do this thing. You can use a calculator. You shouldn't need one, but take one, pass it back. Take one, pass it back. Do your best. If we don't have time to mark today, we don't have time to mark it today, we'll just mark it tomorrow. You can go right to the bell. If you finish, then go visit Denmark. Finish. That was a bad one. I apologize. That was bad. If you finish, you get to sit around and look pretty. Well, I mean, I'll sit around and look pretty. You might sit around and look average. Nothing? Nothing? Man, I hate first block. Nobody laughs at my jokes. Uh-oh, trouble. No, extras come forward. The whole point is Ethan should have stopped and handed them over to here. That Ethan. Not that Ethan. Go. You have till the end of the period. When we mark it tomorrow, mark it appropriately. Right? If you ran out of time, put a little line where you stopped, and you can finish it tonight for homework. All right? I know what I'll do. I'll take attendance. Because it's vitally important.